So previously we learned how to calculate the amount of product that we can form from a reaction. But that doesn't necessarily represent the types of situations that we have all the time in the lab. We might not have enough of one reagent or the other in order to get that theoretical yield. And so what we have to concern ourselves with is what's known as a limiting reactant. The limiting reactant is the one that's going to limit how much product we can form. And if we think back to our example that we did previously, that was uh, not chemistry related. I was just going to copy and paste that, but we'll go back to what we did. So remember our bagel recipe. 12 bagels require, and we said we're just going to ignore the water. 4 cups of flour, half an ounce of yeast, 3 tablespoons of sugar, and 1 tablespoon of salt. So let's say we open up our cabinet and we find that we have 8 cups of flour, 20 ounces of yeast, 24 tablespoons of sugar, and 12 tablespoons of salt. If that's what we have available to us, now we can again ask the question, how many bagels are we going to be able to make from that combination? So how do we think about this? Well, we can do it in the following way. So if we think about the salt, we said we have 12 tablespoons of salt. Well, we know that we only need 1 tablespoon of salt. So 1 tablespoon of salt is enough to make 12 bagels. So therefore 12 tablespoons is enough to make 144 bagels. We also said we have 24 tablespoons of sugar. So we have more sugar available than salt. But we also need more sugar because we need 3 tablespoons. So even though we have twice as much sugar available to us as we do salt, that amount of sugar is only enough to make 96 bagels. So we can already see we have way more sugar than what we can, I'm sorry, way more salt than what we can use. How about the yeast? So we have 20 ounces of yeast. But we only require half an ounce. So here we've got enough yeast for 480 bagels. So clearly we're not limited by the amount of yeast that we have. And then our final one, we said we have 8 cups of flour. Our recipe requires 4 cups of flour, so our flour is actually only going to allow us to make 24 bagels. So overall, we have our ingredients here, but the one that is limiting is the flour. And the flour is limiting because it's the amount of flour that we have will make us the smallest number of bagels. So if these are our conditions, that we have this many of our ingredients available, we went through, we calculated how much of the product each of those would allow us to make, and we could see that the flour was our limiting compound. So it becomes the same thing with chemicals. So let's do an example and see how this works with an actual chemical reaction. So phosphorus plus chlorine reacts to form PCl3. And we're going to say that we have 100 grams of phosphorus and 200 grams of chlorine. So I want to ask 2 questions here. The first one is, what is our limiting reactant and what will be left over? And what I mean by left over is, if we think back to this previous example, we were limited by the amount of flour that we had. We had enough flour to make 24 bagels. So that would have required that we use 2 tablespoons of salt. So we would have had 10 tablespoons of salt left over. So we're going to now do that for phosphorus and chlorine in this reaction. So in addition to figuring that out, we're also going to figure out how much PCl3 that we can form. So what's our first step here? Hopefully you said our first step is that we need to balance our equation. All right, so we've got 2 different calculations that we need to do. We're going to do the phosphorus calculation and the chlorine calculation. So let's do phosphorus first. So 100 grams of phosphorus, 1 mole of phosphorus is 30.97 grams. We then need to convert from moles of phosphorus to moles of PCl3. We get these numbers from our balanced equation, so 2 moles to 2 moles. And then we can convert from moles of PCl3 to grams of PCl3. And we find that our 100 grams of phosphorus is enough to make 443.4 grams of phosphorus trichloride. Now, that doesn't tell us what's limiting yet, because we've got to do the same calculation for chlorine. So we're going to do the exact same calculations here for chlorine. Again, we're starting with 200 grams of chlorine. So at least initially, we might think, well, we've got more chlorine. But this is why we always talk about, you know, mass versus moles, because it's not the mass that matters, it's the number of moles. And a mole of chlorine actually has a mass of more than double a mole of phosphorus. We then, again, our coefficients, we need 3 moles of chlorine to make 2 moles of PCl3. And finally, our final conversion factor is going to be the same, to convert from grams of PCl3 into moles. I'm sorry, from moles into grams. And so we find that this 200 grams of chlorine is enough to make 258.2 grams of PCl3. So we can see from that, what's our limiting reactant? Our limiting reactant, even though we have more of it, our limiting reactant here is the chlorine. How do we know? Again, we know that based on the fact that the amount of chlorine we have allows us to make less PCl3 than the amount of phosphorus that we have. So 258.2 grams is the maximum amount of PCl3 that we can form given these starting conditions. And this 258.2 would be our theoretical yield. It's the maximum yield that we can form given the amounts that we started with. So now our second question is, what's left over? So we know all the chlorine's being used up. That's our limiting reactant. So of the phosphorus, how much of the phosphorus is left over? Most straightforward way to do that calculation is to decide and to determine from 200 grams of chlorine, how much phosphorus does that require? So same calculations as before. We're going to go from moles of chlorine or grams of chlorine to moles of chlorine. Then we're going to go from moles of chlorine, but in this case, we're not going to moles of product, we're going to moles of the other starting material because we're trying to determine how much phosphorus we need. And then we can go from moles of phosphorus to grams of phosphorus. And what this calculation shows us is that we needed 58.24 grams of phosphorus to react with the 200 grams of chlorine. So much less than the 100 that we had. So how much phosphorus is left over? Well, if we started with 100 grams of phosphorus and we use 58.24 grams of it, then what's left is 41.76 grams of phosphorus. So let's do another example. Here we're going to start with C8H18 have that react with oxygen to form carbon dioxide and water. This is actually C8H18 is octane, which is something you might be familiar with, as octane is in some form it is gas, gas that you'd put in your car. And so this reaction is the combustion or the burning of octane. So if we have 100 grams of octane and 20 grams of oxygen, what's the limiting reactant? And then what are the theoretical yields of both of the products? So first thing you want to do is balance the equation. So take a few minutes, pause the video, and go through and balance this equation. This one's a little bit more complicated than some of the ones we've done previously. So hopefully you've got this equation balanced to 25, 16, and 18. So we're going to figure out our limiting reactant. So I'm going to start with 100 grams of octane and 20 grams of oxygen. And we'll just start out by figuring out how much carbon dioxide each one of these will form. So in both cases, we're going to start by using the molar mass. Our second step will be our mole conversion. And then convert from moles of CO2 into grams. So we've got two calculations to do. So what do we get in each case? So for the octane calculation, we get that 100 grams of octane is enough to form 308.8 grams of carbon dioxide. How about for our oxygen? So we find our 20 grams of oxygen is actually only enough to make 17.6 grams of carbon dioxide. So clearly, in this case, the oxygen is our limiting reactant. Now, we can also, again, do the other half, which is to figure out the amount of water. That's going to be the same calculation we did at the bottom, except we're going to replace our terms that have carbon dioxide, we're going to replace those with water. So 20 grams of O2, 1 mole over 32 grams. Then we get 18 moles of water are formed from 25 moles of oxygen, and then we can convert to grams. 18 grams of water is 1 mole of water. So we can form 8.1 grams of water. We don't need to do the other calculation. We don't need to go through and do the C8H18 to water, because we already learned in the previous calculation that oxygen was our limiting reactant. And so if it's the limiting reactant for one, it's going to be the limiting reactant for both.